All right, so I'll fly through these solutions for you. Thanks a million for all the people who got in touch with their attempts at questions and also letting me know the ones they couldn't do. So I think barring one or two, everybody had kind of a question on something. So I will just go through them. Okay, so this one, I think if we bring the 2 to the end as a power, we get log to the base 10 of 3 squared plus log to the base 10 of 16. And then if we do the same thing here, so bring the 2 to the end, we get 6 over 5 squared. So that's log to the base 10 of 9 plus log to the base 10 of 16 minus log to the base 10, and this is going to be square the top 36, square the bottom 25. This is an addition, so we can multiply these two. So it's log to the base 10 of 144 minus, now this one is a division. No, can I do anything with that? I don't think I need to actually. Hang on, sorry. So if I go log to the base 10 of 36 over 25. So this is a subtraction, which I can turn into a division. So if I go up here, we get log to the base 10 of 144 over 36 over 25. I don't know if we come across this yet, actually. Dividing by a fraction. Like it's a junior cert thing, but just that we haven't come across it. So when you're dividing by a fraction, we KFC. So we keep the top, we flip the bottom, and we change divide to multiply. Sorry. Yeah, so it was log to the base 10. We keep the 144. We make it 25 over 36, so flip. And then instead of divide, we multiply. So that is 100. And then log to the base 10 of 100 is 2. Okay, this one. This looks a bit easier. So bring this to the back again. So we get log to the base 3 of x squared minus log to the base 3 of 18 minus x equals 1. This is a subtraction which we turn into a division. So it's log to the base 3 of x squared over 18 minus x equals 1. This is the argument. The variable is in the argument. So we have to switch to indices. All right, so the base of the log is the base of the indice. The answer to the log is the power. And then the argument, which is here, is the answer. So 3 to the 1 is the same as 3, so we don't need that. I'm going to multiply here by 18 minus x to cancel the fraction, and I'm going to multiply here by 18 minus x to balance it out. So this is 54 minus 3x equals x squared. If I plus 3x to cancel, and then minus 54 to cancel, I get a x squared plus 3x minus 54 equals 0. So the guide is minus 54. Factors of minus 54 to make 3. 6 by 9. I need plus 3, so it's plus here and minus here. That is x squared minus 6x plus 9x minus 54 equals 0. We'll go green and red. X times x minus 6 plus 9 times x minus 6. So that is x minus 6 and x plus 9. Let each bracket equal 0, so x minus 6 equals 0 and x plus 9 equals 0. So x equals 6 and x equals minus 9. Yep. Sorry, I was just checking if there was any restrictions in the question. Like that the x value had to be positive or anything like that, but there isn't. So good to go. This one looks similar. Bring this to the end as well. Oh, no. I'm going to have to switch bases here. Okay. So log to the base 3 of x plus log to the base x of 3 cubed equals 4. So log to the base 3 of x plus log to the base x of 27 equals 4. Now, I need this base to be a 3. So I want the base to be a 3. And the top bit, oh, it's going to put my x in the bottom. Okay. Right. Oh, that's a 4. So I can do this. That's a 3. I mean, you can keep working with the log to the base 3. But I'm just going to swap it to make it look a bit easier. So I get y plus 3 over y equals 4. And then I can multiply across by y. So that gives me y squared, doesn't it? Sorry. If I multiply here by y, multiply here by y, and multiply here by y. Yeah, y by y is y squared. This one I just get a 3, and this one I get a 4y. So y squared minus 4y plus 3 equals 0. Oh, sorry. Obviously you can solve that any way you want, but we have been doing guide, so let's do guide. So it's going to be 3 by 1 minus minus, so y squared minus 3y minus 1y plus 3. 2 brackets. So this is y and y minus 3, minus 1 and y minus 3. And that gives me y equals 1 and y equals 3, log to the base 3 of x. So I get log to the base 3 of x equals 1. And log to the base 3 of x equals 3. So again, the argument is in the the unknown is in the argument, or the variable is in the argument. So I need to switch to indices. So the base of the log is the base of the indice. The power, or the answer, becomes the power, and that equals x. So x is 3, and then on this side, 3 cubed equals x. So x is 27. Fab. Right, this one. These actually come up a bit. I know most of you said you could do the first two, and the problems when you started after that, but I will have a look. So log to the base 3 of 15. Could that be log to the base 3 of 5? No, because we'd multiply and get 25, so that doesn't work. So it would have to be that. Because then the addition would become a multiplication. Yeah, okay. So this worked. And log to the base 3 of 3, you can double check on your calculator. But that is 1, and log to the base 3 of 5 is a. So that is in terms of a. This is division, which we can turn into a subtraction. So log to the base 3 of 5 is a, and this is 1 again. Okay, the third one. A mixed fraction. So you do 3/8 are 24 and 1 is 25 over 3. So that is log to the base 3 of 25 over 3, which is log to the base 3 of 25 minus log to the base 3 of 3. And this actually now is the thing I accidentally did with the first one. So I can do log to the base 3 of 5 plus log to the base 3 of 5 minus log to the base 3 of 3. Yeah, because this is an addition. So I would multiply these two to get this. So that works. And log to the base 3 of 5 is a, plus log to the base 3 of 5 is a minus 1. So 2a minus 1. For that one. Ooh, 25 and 27. Okay. So the division can go straight to a minus. This is going to be log to the base 3 of 5 plus log to the base 3 of 5. The exact same thing we did over here. Now this one. Log to the base 3 of 3 plus log to the base 3 of 9. Does that work? The plus means I multiply those two to get this. So that does work. 3 9s are 27. Okay, this is a. This is a. This is 1. Now, wasn't there a 9? can I make it log to the base 3 of 3 squared and then bring this to the front? Yeah, I think that's going to work. Okay, so a plus a is 2a minus 1 plus 2 log to the base 3 of 3. And log to the base 3 of 3 is 1. So we get 2a minus 1 plus 2 times 1. That's 1 plus 2 is 3. The whole bracket thing here, this is just, without patting myself on the back and saying it's good maths, it's good maths. If you're doing a minus into, see the way the minus was going into like a compound thing, so two things, the minus has to impact everything that comes after it. So it's just a really good, it actually didn't end up mattering here because they were all positive, but sometimes it does have an impact. So anytime you have a minus, basically protect everything that comes after the minus by using a bracket. It's a really simple mathematical tool, but it can actually solve a lot of problems. Okay, and then this one, log to the base 3 of 75. 25 and 3. Oh. Yeah, so 3, the plus is multiplication, and this by this gives you 75. Grand. This I've done before, so it's 5 plus log to the base 3 of 5, and that's just a 1. So it's a plus 1, which is 2a plus 1. There you go. Hope that makes sense. Like, if any of these solutions, even after me explaining it, doesn't make sense, just let me know. Obviously, I'll probably just save it until I come back, but I will go through it with you. Okay, so P is this thing, Q is this thing, and OR is that thing. Show that P plus Q equals OR. So log to the base A of 21 over 4 plus log to the base A of 7 over 3 is supposed to equal this. Okay. So I'm going to turn the divide into a minus. And I'm going to do it again. Seven and 2. I can split, sorry, 7 and 2 is coming from here. I have a 7. Okay, I'm going to try splitting the 21 up. So log to the base A of 7 plus log to the base A of 3 minus log to the base A of 4 plus log to the base A of 7 minus log to the base A of 3. So these cancel, and I've got 2 of those. So 2 log to the base A of 7 minus log to the base A of 4. Trying to get log to the base A of 7 over 2. Now I wonder, could I do 2 log to the base A of 7 minus and split this up? Okay, that actually I think this might work. So if I go up here, I've got 2 log to the base a of 7 minus 2 log to the base a of 2. Oh, I'm so close. So if I bring my powers to the back, I get log to the base a of 7 squared minus log to the base a of 2 squared. I can turn my minus into a divide, so log to the base a of 49 over 4. And if I simplify 49 over 4, how do I get rid of... Oh, sorry. I didn't read it properly. Hang on. Bear with me. Okay, don't simplify it. Watch. Okay, so if both parts of the fraction are squared, I can just take the square outside. And then I can bring the square to the front. And if you actually read the question, P plus Q needs to equal 2 or. That's exactly what I have. Or is log to the base a of 7 over 2, and I have 2 log to the base a of 7 over 2. So I have 2 or. So I did it. The importance of reading the question. Okay, and then these two, oh, these look grand. So the plus will be a multiply. So log to the base 2 of x times x minus 2 equals 3. Log to the base 2 of x squared minus 2x equals 3. The variable is in the argument. So 2 cubed equals x squared minus 2x. What's that, 8? Equals x squared minus 2x. So x squared minus 2x minus 8 equals 0. The guide is 8, so it's going to be 4 times 2 minus 4 plus 2. So that is x squared minus 4x plus 2x minus 8. Okay, so out of the blue bracket, we'll take the x, leaving x minus 4. And then take out 2, leaving x minus 4. So x minus 4 is the first factor, x plus 2 is the second factor. So we get x equals 4 and x equals minus 2. And then the other one. Sorry, I'll highlight it in this colour. And then bring it down here. Okay, so that's going to be a subtraction into a division. So log to the base 10 of x squared plus 6 over x squared minus 1 equals 1. The variable is in the argument, so it's 10 to the power of 1 equals x squared plus 6 over x squared minus 1. We don't need the power of 1. I can multiply by x squared minus 1 to cancel and multiply here by x squared minus 1. So I get 10x squared minus 10 equals x squared plus 6. If I minus x squared here to cancel, minus x squared there, and minus 6 here, minus 6 here. That is 9x squared minus 16 equals 0. Well done if you recognized this. It's a difference of 2 squares. So 9 is 3. squared, and x squared is x squared. 16 is 4 squared. And then you do first minus second, first plus second, and let each part equal 0. So that is 3x equals 4, x equals 4 over 3, and 3x equals minus 4, x is minus 4 over 3. 24, yep, 23, is there a reason why we only have one answer? Minus 2 plus log. Yeah, so if you sub, it should be clear, but if you sub this in, you get an error. So that answer gets rejected. And what's this one? 11. Oh yeah, that definitely worked because it was a proof. Yeah, that's fine. Question 7. 1 plus a minus 1. 1 plus a minus 1. 2a minus 1, 2a minus 3. And then 2a plus 1 for the last one. Yep. Oh, there's not going to be a solution to that one. They're both positive though, so they should both work. Now this one possibly should have rejected the minus 9. Let's try sub it in. So 2 log to the base 3 of minus 9 minus log to the base 3 of 18 minus 9. And out equals, yeah, that's an error. So this gets rejected as well. And here I just got 2, so that one should be fine, and that's it. Right, so that's the homework from when? Is that Wednesday? Yeah, that's Wednesday. I'll do Thursday in a minute.